Hey, what's up? It is Tuesday, April 29th. Yeah, we're almost out of April. I'm gonna try and get this done in 10 minutes or less. So you guys see what it is. Pause it if you need to get the agenda. Again, pause if you need to get the agenda, but we are going to be moving forward. By the way, what element is not on the periodic table? What element is not on the periodic table? Hopefully you got it. The element of surprise. That's right. The element of surprise, not on the periodic table. By the way, what element is atomic number 30? Hopefully you should know this. It is zinc. Hopefully you got that. It is the real atomic number 30 is zinc. In a world where you can be anything, be kind. Let's keep it pushing. Okay, just so you guys know, open house is this Wednesday. That means it is tomorrow, April 30th from 5:30 to 7 p.m. Bring your parents in and have them check out some of the things you've done. I'm going to have some flashcards and things on display. If you would like your flashcards on display, please let me know. But bring your parents in and kind of walk them through some of the things that we have learned and done this year. I will have those things on display. All right, let's keep it pushing to the next thing. I just wanted to talk about this for a second. This is not something you have to like write down but I want this just to be in your brain, okay? So we kind of talked about these lanthanides and actinides down there, right? As we talked about Marie Curie, right? And so I just wanted to put that out there that, hey, these ones at the very, very bottom, they are called the lanthanides. That's what family they're called. And then the actinides. So these are like the locations and the family name. So again, we're just going to talk about them. So the alkali metals, these are these ones all the way to the left, starting with hydrogen, lithium, sodium, potassium, and as you guys know, like they are highly reactive. Just know that they are highly reactive. Then you have the alkaline earth metals. They're in what we would call this second column, right there. And then this big section in the middle here, that section really is called the transition metals. So those as a whole are the transition metals. And then the ones that probably are the best for memory are the noble gases, and those jokers are all the way to the right. And yes, hopefully you've guessed it, that those ones, state of matter, is typically a gas. And then you have the halogens, which are right next to them. And they also do often appear as gases as well. If you think about to the left over there, to that part of the table, most of those are going to be metals. And as you go to the right over here, you got a lot of gases. There are the chalcogens, and those ones aren't as talked about, but you got oxygen, sulfur, selenium, right? So I just wanted you to guys kind of have a general idea and layout. This is nothing that is going to be on the test. I just wanted you to have some information about the periodic table. Let's keep it pushing. All right, so we talked about this already, about chemical formulas, right? And about like how do we know how many is in each one. Remember that the subscript, again, only belongs, only belongs to the element to its left. So this 2 only belongs to hydrogen, so there's 2 hydrogen. And if there is no subscript, then that means it's only 1, so there's 1 oxygen. So we talked about that before, and we're going to take a little bit of practice. So go ahead and write these down, the molecular formulas, and then write down how many atoms of each element and how many there are in total. So go ahead and do that, and pause the screen and do that. All right, y'all, did you get that done? Hopefully you did. So let's just go in here and then just start knocking these ones out. So hopefully you're like, oh, this is carbon. All right, cool. So we'll just write carbon in there, right? Carbon. And then we got hydrogen, right? Hydrogen. And oops. And then the last one we got, and I'm just going to put oxygen over here. Boom. Right? Oxygen. Okay. And then how many carbons do we got? We got 3. How many hydrogens do we got right there? We got 4. And then how many oxygens do we have? We have 2. So as we're going down, that's all you got to do for each one. So if you look at this next one, it looks like we have carbon, hydrogen, nitrogen, and oxygen. So for the carbon, right, we're going to end up with, it looks like, boom, right here, 6, right? Okay, cool, 6. Then for the hydrogen, and again, this 15 only belongs to the hydrogen. So then we'll put that right there, hydrogen, boom, and that is going to also be 15. And then the N, which is the nitrogen, right? Cool. there is no subscript here, so that means it's just 1. And then for the oxygen, again, it looks like we end up with, how many we got there? Boom. It looks like 3. Okay, cool. So, I'm not going to talk too much about the rest of them. Most of them are done the same way. Hopefully you got that. Let's just take a look down at this one. And this one is the only one that really is tricky. So what is this Na? Hopefully you know, okay, that's sodium. And then what is the B? Oh, that's boron, right? And then we have the O, which is 7. Now, borax is a common thing that you use as you can use it for washing clothes, but you also, what you guys might commonly use it for is for making slime. Yeah, that's a common ingredient in making slime. So this Na, which is sodium, right? It looks like it has 2. All right, cool. And then the boron, boom, is equal to, it looks like 4. Okay. And then we got oxygen, which is 7 right there. So we got oxygen, right, which we have a 7. Okay. And then we got this over here. So now we got some more. Now, we haven't done a coefficient where it was out in the front. Now, this does just like what we would do in multiplication. Okay. So this gets distributed. So the law of distribution. So it would be for the hydrogen, and then it also would be for the oxygen. Now, how many hydrogens do we have right here? Hopefully you see, oh, it's 2. So then 10 times 2 hydrogen is how much? 20. So hydrogen, I just wanted to show you guys that. So it's 20. Now, the number of oxygen in this total chemical formula is actually going to be more because, here, let's move on over. It is this first 7 oxygens right here, but then it's also, since this is 1 oxygen, 10 times 1 is going to be plus 10, which means the number of oxygens that we really have is 17. Hopefully that wasn't too crazy for you, okay? So make sure to have that completed in your notes and go ahead and do the other 2. I'm not going to walk through those 2. Make sure you get the one for ethanol and then for stearic, hopefully I'm pronouncing stearic acid. Okay, so we're going to keep it moving so we can get this lesson done. All right, now this is, I do want to say, first of all, this is a worksheet. Okay, so number one, that is that. And you need to show your work for the neutrons. So make sure that you show your work for the neutrons. Pause, and I'm going to get myself a better version of this. All right, so I got myself a little screen to write on. So we're just going to pick one of these at large. And you know what we're going to pick? We're going to pick fluorine. So this is the one model that I'm going to do for you. The rest of them, you guys are going to have to figure out on your own. Again, there is a worksheet for this. You should be able to just pick that up in class. If not, there's a digital version of this worksheet on the assignment. So remember, the atomic number is the number of protons, so that is 9. And then these are all neutral atoms, so then the number of electrons also is 9. Now, how do we calculate the number of electrons also is 9. It has the same amount of positive protons and negative electrons. So 9 and 9, that's that. I misspoke. The number of neutrons, this is how we calculate it. We take the atomic mass and we subtract the atomic number. Again, I got that number from right here. Boom. That's where I got it from. And then what is left is 10, which means the number of neutrons for fluorine is 10. We did this yesterday, right? And I'm giving you an example right here. Complete the worksheet, scan that thing, and turn it in. Last thing that we're going to do. All right, cool. So make sure to get this worksheet. And again, you just need to scan it and turn it in. Don't lose the worksheet. Keep it. Make sure to show your work for the neutrons, okay? The other parts, you don't have to show your work. But again, show your work for the neutrons. All right, cool. Then you guys also have one more ed puzzle to complete. So make sure to go over to this Crash Course Chemistry. Get this completed. So you've got a full day. You do not have time to mess around. Be about your business. Handle it. You got a full day of work. And that is actually everything for this class. If you get done with those things, then go ahead and start studying for the test. Again, start studying for the test. All right, y'all. Peace. Oh, make sure as well to play this video to the end. If you don't play it to the end, you will not get credit for the end puzzle.